Seismic waves are produced by earthquakes that travel through the Earth. Here the word seismic just means to do with earthquakes or vibrations in the Earth. Here's an image of an earthquake happening. Shifts in the tectonic plates that make up the Earth's crust have caused tremors, which have damaged buildings and the ground. The earthquake causes seismic waves to travel through the Earth. Now these waves carry large amounts of kinetic energy, and they cause buildings and the ground to shake as this energy is given to them. The fact that they receive so much energy so quickly is what causes them to be damaged. But what are the properties of these waves? There are two types of waves that will be produced in an earthquake. The first are called P waves. Now P waves are longitudinal seismic waves. Here the P stands for primary, as these are the waves from an earthquake which will usually reach us first. They will have different speeds in solid and liquid rock. Here's a diagram representing a boundary between some solid rock and some liquid rock. Now the rock here has changed state because of high pressure or heat. The P wave is caused by matter in the Earth moving back and forth. We can represent this in a diagram by drawing the compressions like so, similar to how we draw sound waves. When this wave crosses the boundary between solid and liquid, it will slow down. We can show this by drawing a wave with a shorter wavelength. Since the frequency of the wave doesn't change, the speed decreasing means that the wavelength decreases. Now let's look at the other type of seismic wave. S waves are transverse seismic waves. Here the S stands for secondary, as these waves normally reach us sometime after the primary waves. It's important to note that most earthquakes will be producing P waves and S waves at the same time. The primary waves just travel faster and reach us first. Since an S wave is a transverse wave, we represent it with this familiar pattern that looks like a water wave. Here, the matter in the Earth is moving up and down instead of back and forth. However, S waves also work differently to P waves since they cannot travel through liquids. So when this wave reaches the boundary between the solid and liquid rock, it is stopped and it can't transmit it to the liquid. It will be absorbed by the liquid or reflected back into the solid. You don't need to know why S waves behave this way at boundaries, but you do need to be able to tell the difference between P waves and S waves and identify which is which.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!